In this video, we will talk about how to write trig functions as algebraic expressions. So I have two examples for us to work through here. Let's check out this first example. We have the cosine of sine inverse of x. How can we rewrite this trig function as an algebraic expression? In other words, how can we rewrite this so that we're not using these cosines or inverse sines or any other trig functions? Well, the trick is we first need to focus on the inner parentheses right here. So the sine inverse of x. This is the equivalent of the sine of some angle is equal to whatever's inside these parentheses, so x. So knowing that you can rewrite this in this manner is probably the most important step in this whole process. Now, if we want, we can write x as x over 1, and here's why. If we imagine that we have a right triangle right here, and we're saying we have some angle where the sine of that angle is equal to x over 1. Now, if you'll recall the acronym SOHCAHTOA, the sine of an angle is calculated as the opposite side divided by the hypotenuse of the triangle. So the opposite side, we're told, is x. So let's write an x right here, divided by the hypotenuse, which we're told is 1. So that's step one. Next, we're going to move to the outside of the parentheses and say, okay, what's the cosine of that angle? So the cosine is the adjacent side divided by the hypotenuse. So the adjacent side right here, if we want, we can write an a. We need to figure out what is this divided by the hypotenuse. So since we have a right triangle, we should be able to say that a squared plus x squared is equal to the hypotenuse squared, which is 1. So let's write that. Let's say a squared plus x squared is equal to 1 squared. Remember, we're trying to figure out what a is, so we're going to solve for a here. So we can subtract an x squared from both sides, and we get a squared is equal to 1 squared is just 1, so we'll say 1 minus x squared. And to solve for a, we can take the square root of each side, so we get a is equal to the square root of 1 minus x squared. So this a right here, this is really the square root of 1 minus x squared. So the cosine, we said that's what we're trying to find, is the adjacent side, so let's write that, the adjacent side divided by the hypotenuse, which is 1. So this is our final answer, and if we want, we can just write it as the square root of 1 minus x squared. So that is how we can write this original trig function as just an algebraic expression. All right, let's try one more example. Let's say we have the sine of the tangent inverse of 3x. How can we rewrite this as an algebraic expression? Well, once again, we'll start with these inner parentheses, and we'll start by recognizing that the tangent inverse of some value is the same as the tangent of an angle is equal to whatever value is in these parentheses, which is just 3x. So that's step one. And remember, we said we could rewrite this 3x as a 3x over 1. That's equivalent. So if we imagine our right triangle, and we have some angle here, we're saying that the tangent of this angle is equal to 3x over 1. So again, if you think about SOHCAHTOA, the tangent of some angle is calculated as the opposite side divided by the adjacent side. So the opposite side of the angle is over here, that's 3x, divided by the adjacent side, which is right here, is a 1. So now that we've written that, we can move to the outside of the parentheses and say, okay, what is the sine of this angle? Well, the sine is the opposite side divided by the hypotenuse. So the opposite side divided by whatever this hypotenuse is. So let's figure out what this hypotenuse is. So since we have a right triangle, we can use the Pythagorean theorem again and say 1 squared plus 3x squared must be equal to, let's call this side h squared. So we get 1 squared, that's 1, plus 3x squared, so 3 squared is 9, x squared is just x squared, is equal to h squared. So to figure out what h is, we can take the square root of each side, and we get h, or the hypotenuse, is equal to the square root of 1 plus 9x squared. So remember, we're trying to find the sine of this angle, so that's the opposite divided by the hypotenuse. So our final answer will be 3x divided by the hypotenuse. Remember, we just figured that out. That's the square root of 1 plus 9x squared. Now, if we'd like, we can rationalize the denominator, which means we can get rid of the radical in the denominator by multiplying both the numerator and the denominator by this radical. So in the numerator, we get 3x times the square root of 1 plus 9x squared, And in the denominator, when we multiply these two square roots together, the square root sign goes away and we're just left with 1 plus 9x squared. So that is our final answer. That's how we can write this original trig function as an algebraic expression.